We're going to learn about hyperbolic geometry today. So we'll start out with the characteristic postulate of hyperbolic geometry. And this is what makes it different from Euclidean geometry. And it says, through a given point C, not on a given line AB, passes more than one line in a plane not intersecting a given line. So it's saying that, as you see in this picture, we've got the line CE and CD. It's saying both of those lines will not intersect AB. In Euclidean geometry, there's only one line through a point that won't intersect the other line. Here we've got two. Okay? The relationship described in the characteristic postulate is pictured if it is assumed that C, D, and C are two distinct lines through C, and neither intersects AB. So what we have is, through a given point C, not on a given line AB, pass an infinite number of lines not intersecting the line. This statement is saying, okay, so CE and CD don't intersect A, so any of the lines in between CD and CE, so all these red lines I'm drawing, none of those lines will intersect AB. All right? So it's, like I said, it's a different way of thinking about things. None of those lines are going to intersect AB. It talks more about that here in the next slide. So in hyperbolic geometry, the first lines in either direction through a point do not intersect a given line are parallel lines. These are sometimes called the sensed parallel lines. According to these technical definitions, there are exactly two parallels through C to AB. Right? There's a right-hand parallel, CE, and a CD. So CD is the right-hand parallel, and CE is the left-hand parallel. The angles FCD and FCE, so these two angles are the angles of parallelism for the distance FC. All right? The two angles of parallelism, so FCD and FCE, are congruent and acute. They're congruent and acute. All right. So usually you think, oh, well, if they're the parallel lines, they have to be perpendicular to FC. They're not. They're acute and they're congruent. There can be with the angles of parallelism, they cannot be right angles, as shown in Figure A, because assuming this fact and also the characteristic postulate of hyperbolic geometry leads to a contradiction. Furthermore, the angle of parallelism cannot be obtuse. And so we look at Figure B, because it would have a non-intersecting line CA within the angle. This would contradict the fact that parallel is defined to be the first non-cutting line. That's key. It's the first non-cutting line. So the line that is perpendicular to CF, it does not intersect the line that this line down here, it does not intersect this line, but because it's perpendicular, but it's not the first non-cutting line. The first non-cutting line, which is going to be something going like this, that's your parallel. This perpendicular is outside of it, right? So it's going to be in between the other one on this side. It's one of those lines in between that doesn't intersect. So there's multiple lines on each side of FC that don't intersect the bottom line, but the one that's parallel is the first non-cutting line. Any questions? Okay, so that's the thing about the parallel lines. Now we're going to talk about curves and hyperbolic geometry. There's a few homework questions over this section, so we'll talk through it and go from there. So curves and hyperbolic geometry. We have a definition. Circle it's the same in hyperbolic geometry as Euclidean. The set of all points equidistant from a given point. For any 2 points A and B on an ordinary circle, angle AOB and angle OBA are congruent, where O is the center of the circle. That's because AO and BO, we know these are radii, right? The radii are congruent, so that's isosceles triangle. The base angles would be congruent. This leads to a generalized definition of corresponding points. 2 points, one on each of 2 lines, are called corresponding points if the 2 points form congruent angles on the same side with the segment whose endpoints are the 2 given points. In the above figure, A and B are corresponding points because of the congruence of the angles AOB and OBA. Points CB or C and A, C and B or C and A, similarly can be shown to be corresponding points. In fact, any 2 points on a circle are corresponding points. They all correspond because they're going to make the same angle with O. Ordinary circle. The set of all points corresponding to a given point, not the center, on a pencil of rays with an ordinary point as the center. The pencil of rays is all the rays in a plane with a common endpoint. Okay, so what we're talking about are, what we have is with this pencil of rays, we have a point on the circle. It may be A, and we draw that to E, and then we use the same point A, and we've got D, C, and then A and B. Alright? Because the tangent to the circle is perpendicular to the radius at the point of contact, A circle can be considered an orthogonal trajectory of a pencil of rays with an ordinary vertex. Alright, now here's the important part of what we're talking about, is the equidistant curve. You'll have some homework questions on the equidistant curve. An equidistant curve is the set of all points corresponding to a given point on a pencil of rays with a common perpendicular. So if we let A, B, and C be any 3 points on an equidistant curve, okay, that curve doesn't look like it's equidistant from the line DF, but it is, okay? Then the common perpendicular DF is called the baseline. The quadrilateral ABE is a Saccheri quadrilateral. Since A and B are corresponding points, and BAD is congruent to ABE, these two angles are congruent. The name equidistant curve is justified because every point on the curve is the same perpendicular distance to the baseline. So all these distances on an equidistant curve, those are all the same. Alright? Now, what they're going to ask about in the homework is the branches of an equidistant curve. So I can go on the opposite direction on this equidistant curve. And that's another branch. Each side is a branch of the equidistant curve. Okay? So the distances, these distances would also be the same. Okay. Any questions on the notes? Any questions? Okay. So, that's it.